Okay, this is Chapter 7, Part 2. We're going to talk about biased sampling. Last time we talked about representative samples, which was the random and all that stuff. Now we're talking about biased sampling. Biased sampling means that we don't necessarily get a sample that's representative of the population. And in reality, in psychology, biased sampling is extremely common. I would say it's more common than representative sampling. So let's talk about them, the different sampling techniques, and in bias sampling. Now, with these, you may not necessarily get a representative sample on the characteristics that you want, okay? Depending on the different techniques that you're looking for. And sometimes that's because you don't care about those other kinds of demographics or characteristics. Let's start with convenience sampling. Convenience sampling is the most common in psychology. It is you take whoever's convenient to you. If it's the next person who walks by, that would be a convenience sampling. If it's someone who happens to be in the room with you, convenience sampling. Someone who happens to be in a class, that would be convenience sampling. Now, convenience sampling is not random. Sometimes we think about, oh, if if I go stand out on the quad and I randomly choose 5 people, that's not actually random sampling. But you're saying, oh, but I randomly chose them. I didn't know who they were. That's still convenience sampling. So let's say that you go out on the quad and you look for the next few people. Now remember, sampling is from a population. For it to be a random sample, that means that each person in the population has to have an equal chance of being in your study. If you happen to choose 5 people who are on the quad between the hours of 1 and 1:15 on a Wednesday afternoon, then that is not an equal opportunity for everybody in the population to be in your sample. It's really just the people who happen to be outside at between 1 and 1:15 on this particular Wednesday. It's not an equal chance. Equal chance would be a random sample. That's a convenience sample, the people who are conveniently available to you. That's the convenience sample. It's the most common. Purposive sampling. Purposive sampling is when you go and advertise for a specific kind of demographic or characteristic that you want to be in your sample. So for example, when you see signs up in the psychology building that say, are you a gamer? Will you come and be in our study? That's purposive sampling. What they're doing is they're looking for a specific characteristic. In that case, it was gamers. I want gamers to be in my study. It's purposive because I go out and purposely look for a specific kind of person. Now, does that mean I'm randomly sampling gamers? No, not at all. What I'm doing is I'm sampling the people who happen to see that particular ad and reply to it. It's a purposive sample because I want a specific characteristic or group. Another way you can get a specific characteristic or group is through snowball sampling. Snowball sampling is when you have one person that you know has a characteristic, and they go out and find somebody else who has that same characteristic. So for example, let's say that I wanted to study libertarians. Well, let's say that I don't have a good list of all the libertarians in Colorado, right? I don't have a sampling frame. But I do know that my friend Libby is a libertarian. And so I go to Libby and I say, hey, would you be willing to be in my study? And Libby says, all right, fine. And then I say, Libby, would you be willing to ask other libertarians that you know to be in my study because I don't know many libertarians? In which case, that's a snowball sample. Libby finds one libertarian, who finds another, who finds another. It's a snowball, and they find each other. Now, this is not representative because it just happens to be the libertarians who knew Libby or knew somebody who knew Libby who were in your sample. Snowball sampling happens quite a bit in psychology when we're talking about developmental psychology. So, for example, you might have heard, hey, do you sometimes see these, especially if you're a parent, do you have a child between the ages of 10 and 12? And then they'll ask, do you know somebody else who has a child between the ages of 10 and 12? The researchers may not know very many people, but people who have kids between the ages of 10 and 12 know a lot of other people who have kids between the ages of 10 and 12. And so it's easier for them to find each other. That's a snowball sampling. Quota sampling is a lot like stratified sampling. That is, you know that the population has a specific proportion of characteristics. So let's say, for example, when we're talking in part one, we knew that 32% of that particular population happened to be Republicans. Well, the way you would do quota sampling is you would still make sure that you get 32% of your sample to be Republican, but you're just not using a random or representative sampling technique to do it. You might use snowball sampling and saying, hey, I need, you're a Republican, can you find some more Republicans for me? And then when you hit 32%, you stop. It's not representative because you're not using a random or representative sampling technique. You're just stopping when you have the proportion that you want, right? So in this particular case, the difference between a quota sampling and a stratified sampling technique is that in a quota sampling technique, you're using a non-representative, like a non-random sampling technique, for example, convenience or purposive or snowball sampling, to get that proportion. Whereas in stratified, you're using a random sampling technique in order to get those stratas. Okay, now let's go ahead and do some examples. All right. Let's do some examples. And the example that we are going to do has to do with monarchs. So before we do this one, actually, let's go back. We're going to test you on all the sampling techniques. We're going to test you on both representative as well as biased sampling techniques. And you need to tell me what kind of sampling technique I've used. So let's say that I've invented a time machine so I can talk to anybody that I want to. And let's say that I'm interested in all monarchs of Europe first. Let's start with that. I'm interested in all monarchs of Europe. And so let's say that what I do is I go and I choose 5 countries in Europe. I choose Portugal, I choose England, I choose Denmark, I choose Hungary, and I choose France. And I randomly chose those 5 countries. And then in my time machine, I go and I talk to each monarch from all 5 of those countries. What kind of sampling technique have I used? That would be cluster sampling. The clusters are the different countries. I don't have a list of all the monarchs of all those countries, so I randomly, out of all of the countries in Europe, which I do have a list of, I choose those 5 countries, and then I talk to all of those different monarchs. Now, what if I had done the same thing? I had chosen those 5 countries, which I can't remember which ones I told you right now, and then after I chose those 5 countries, I took every 4th monarch in those countries, right? So I have Portugal, England, Denmark, France, and Hungary, right? And so within each of those, I take all of the monarchs of Portugal, and then I take every 4th monarch in the monarchs of Portugal. What kind of sampling technique would that be? That would be multi-stage. That would be multi-stage because I started with a cluster sampling, right? I got those 5 clusters. Each country was a cluster. And then within those clusters, I used a random sampling technique within those clusters. Okay, let's change the population now. Let's make the population be monarchs of Portugal. So this is a list of all the monarchs of Portugal. You can see their pictures. Here's all the monarchs of Portugal. I love Portugal. They're great. There's 37 of them, right? So this Manuel II is the 37th monarch of Portugal. He was the last one too before they became a republic, right? Okay. This list of all the monarchs of Portugal is what? The list of all the monarchs of Portugal is a sampling frame. Let's say that I have the time machine so I can talk to any one of these, right? Monarchs of Portugal. And the population is the monarchs of Portugal. And so a list of all the monarchs of Portugal would be a sampling frame because from this list of everyone, I can choose the ones that I'm going to actually talk to. Let's say that I want to know what it's like to be a monarch of Portugal. I don't care about other monarchs in this particular study. I just want to know about the monarchs of Portugal. And let's say that I'm going to choose 6 people to be in my sample. And so a list of all the monarchs of Portugal would be the sampling frame. And from it, I can get 6. Okay, let's say that I have the time machine, I can go, but I only have time to talk to 6 monarchs of Portugal. So I say, all right, I'm gonna go back and I'm gonna find Alfonso the First, and I'm gonna say, hey, Alfonso the First, what other monarch of Portugal should I go see next? And Alfonso the First says, hey, you should definitely go talk to Alfonso the Second. And Alfonso II says, I say, hey, Alfonso II, who should I talk to next? And Alfonso II says, hey, I know that Sancho II would be really into it. And then I say, hey, Sancho II, who should I talk to next? And Sancho II says, you know what, you should really probably talk to John I, João I. And João says, you know what, I think you really should talk to Alfonso V. And Alfonso V says, you know what, the last person you should really get is definitely going to be Sebastian I. Okay? Sebastian. What kind of sampling technique would that be? That would have been snowball sampling, because I started with Alfonso and I asked, hey, Alfonso, do you know any other monarchs of Portugal I can talk to? And he said, yeah, try Alfonso II, and so on and so on. That is not a representative sample. Not a representative sample. In fact, there's too many from the first, the first half of the group. I didn't get anybody from the 17 or 1800s, etc. Just people who knew people. That's all it was. All right. Let's say that I want a sample of 6 monarchs of Portugal. And so what I do is I number them all, right? So Alfonso I is number 1 because he was the first monarch. Sancho is the second because he was the second monarch, etc. I take a random number generator. And with that random number generator, I say, all right, I got random numbers between 1 and 37. And I want 6 of them. So I want monarch number 13. Monarch number 13 is going to be João II, João II. Okay? Then I go back to my random number generators. That's the first person that I got to be in my study. And then the next one is going to be number 11. That happens to be Duarte the First. So Edward, it's Duarte. Duarte the First, that's going to be the second person. And then I'm going to do number 36. That's going to be, is that Carlos? Yep, Carlos the First is number 36. And then randomly generate, I'm going to get 3 more. 14 is going to be Manuel the First. And then I'm going to get number 7, which is Alfonso IV, Alfonso the Fourth. And then the last one is going to be number 34. And number 34 happens to be Pedro V, Pedro V. What kind of sampling technique did I just use? That was simple random sampling. It's the same as if I had reached in and grabbed them out of a hat, except in this case I used a random number generator. That was simple random sampling. Each person had a totally equal chance of being in my study. That was simple random sampling. All right. Let's say that I knew that 2 out of the 37 monarchs were female, because I know that Maria the First and Maria the Second were the 2 female monarchs. So here's Maria the Second. She's number 31, and Maria the First is number 27 over there. Okay. I want to make sure that I have a representative sample including females. So I make sure that even though there's only going to be 6 monarchs in my study, that I definitely talked to Maria the First and Maria the Second. I talked with both of them. And then afterwards, I mathematically changed their answers to be a proportion of all of the 37, right? So mathematically, I take their proportion. I talk to both of them. I include both of them in my sample, and then mathematically take it down. What kind of sampling technique would I use? That would be oversampling. That would be oversampling that I just barely did. All right. What if I put up a sign in the time-space continuum that says, "Are you a monarch of Portugal? Come be in my study." What kind of sampling would that be? That would be purposive sampling. I'm advertising, I'm looking for a specific thing, and I'm letting them come to me. And in that case, maybe I've got, it wouldn't necessarily be representative, because number one, I'd only get the ones who could read, right? Which, those first kings of Portugal probably couldn't read. But let's say that I mainly got the Luises, because the Luises were hanging out. So I got Luis Primero, and I guess he's the only Luis, right? So let's say that I've got all the Pedros. I got Pedro the Fourth, who said, "Hey, I'm hanging out with Pedro the Third," who's hanging out with Pedro the Second, who's hanging out with Pedro the First, and the Pedros come and say, "Hey, we saw your ad." It's purposive because they're the ones who happen to see the ad and came in and talked to us. It's not representative of everybody. All right. What if I couldn't really control my machine very well, so I just chose whoever happened to be living in the palace at Sintra, and I just randomly went in my I went to the palace at Sintra and picked up whoever happened to be there to be in my study at a few different times of Portuguese history. That would be convenience sampling. It's whoever happened to be in Sintra. I wasn't actively saying I'm going to randomly have an equal chance of everybody being there, right? Because Sintra didn't exist for a lot of that, so a lot of them couldn't have been there, right? So not everybody had an equal chance. I just chose whoever happened to have been there. So if I just went to one place and picked whoever I could get who was a monarch who was living in Sintra, then that would be convenience sampling. It's the people who are convenient to me. Okay, let's go ahead and end with one last question. And the last question is this one right here. The college sophomore problem. Some people say that psychology is not a very good discipline because most of the participants in our studies are college sophomores. The college sophomore problem, if it is a problem, would be due to what kind of sampling technique? The college sophomore problem would be due to convenience sampling, right? The reason why there's so many college sophomores is because the researchers of psychology, they're employed in colleges, universities, and sophomores are in their classes, and they have to get extra credit or class credit, and so they're the ones who are in the studies. They are convenient to them. They are not representative of the entire population in socioeconomic status, in oftentimes in race, in religious preference, in political preference, and many different things. They're not representative. So is that a problem? Is a college sophomore problem a real problem? Well, if you're doing if you're doing a correlational study where you're saying, hey, I think that someone's political affiliation is predictive of their income, well, then that might be a problem, because if you're only using college sophomores, you might have a specific political ideation that's overrepresented. You also might have different socioeconomic problems in terms of income, et cetera. That would be a problem. But what about if you're running an experiment and you want to see if exercise affects happiness? Now, in this particular case, it's pretty clear that we're not a representative sample. However, if we randomly assign sophomores, even though there's a convenient sample, we randomly assign you to either exercise or not exercise, and we find that people who exercise tend to be happier, well, that shouldn't be a big problem, because the college sophomores, that shouldn't be just because of them being a college sophomore that would be the case. Many of the experiments specifically that we run in psychology don't particularly care if you're using a convenient sample. And the reason why is because the actual variables that we're studying should still have the same effect no matter what proportion of the population happens to be in the study. A better way to think about this is this. Let's say I'm doing a study on brain damage, right? Let's say that I get convenient sampling. Let's say that everybody in my sample is a white, college-educated male who is a Republican and wears glasses. Let's say that that's everybody in my sample, right? And the way that I'm going to study brain damage affecting memory is half of those white males are randomly assigned to get hit in the head with a hammer. And then, after they're hit in the head with a hammer or not hit in the head with a hammer, everybody has to take a memory test. Does it matter that they happen to be white, college-educated males of the same political orientation? Would hammers hitting somebody in the head affect everybody, no matter their race, no matter their political affiliation, no matter whether they wear glasses? Would it affect everybody the same way? And if you think that hitting somebody on the head with a hammer would affect their memory, then it really doesn't matter how you sample. It matters how you put people into the different groups, whether they should get hit in the head with a hammer or not. That is not a sampling problem. That is an assignment problem. And those are differences that we'll talk about in later chapters. All right, thanks everybody.